6.3 part 2, we're continuing with our log functions. So we're going to be solving equations using our inverse properties of logs. So if we have log base b of b, this is actually just 1. It cancels out. So then we'd just be left with x as our answer. Same thing if we had b to the power of log with the base b, this would cancel out and we'd just be left with x as our answer. So if I had something like log base 5 of 5 to the power of 2, what do you think my answer here would be? 2. The log base 5 of 5 cancels and we're just left with 2 on top. Or if I had something like 6 to the power of log base 6 of 4. What do you think my answer here would be? 4. So it has to be exactly the same in order for it to cancel out. We had a 5 and a 5, 6 and a 6. All right, example 5a. So here I have 10 to the power of log of 4. That log doesn't have a base, but what do we know? If there's no base written, what's it implied that our base is? 10. So I have 10 to the power of log base 10. What would this be? 4. Awesome. 10 to the power of log base 10 cancels, and we're just left with the 4.
And we know it's 10 because if it doesn't say it, has to be.
Right. Whenever the base isn't written, it's implied that it's a 10 as our base. It's implied that it's a 10. All right, let's look at B. All right, so this one's a little bit different too. We have log base 5 of 25 to the power of x. Well, I can't just cancel out the log base 5 and 25, but maybe I could change 25 to look like a 5. 25 would be 5 to what power? 5 to the second power. So I'm going to replace that 25 that I have there with a 5 to the second power. So everybody see what I did there? I just replaced the 25 with the 5 to the second power. So now that I have log base 5 of 5, this cancels, and what am I left with? 2x. Because that x was there too. So I just multiplied these two exponents together. So 2x. All right, let's look at 13. What would this simplify to? X. 8 to the power of log base 8 cancels. We're left with x. Awesome. For 14, what does this simplify to? Negative 3x. Log base 7 of 7 cancels. We're just left with the negative 3x on top. $15. Here we can't get anything to cancel out right away, but let's see if we can change 64 to be 2 to some power. 2 to the 6th power. So I'm going to change 64 to be 2 to the 6th power. I'm just going to rewrite it here. So log base 2 of 2 to the 6th power, and that x is still there. So what would this simplify to? 6x. Awesome. Log base 2 of 2 cancels. All right, let's look at 16. So here it looks a little bit different. We have ln's here. What does ln come from? We talked about this yesterday. It's log with the base of what? Log with base e. So this would be like e to the power of log base e. Log base e and ln are the same thing. So e to the power of log base e cancels, and what am I left with? 20. So if you have an ln, you know that it's going to cancel out with the e. So you don't really have to change it to log base e. I'm just showing you that these are the same, but they're going to cancel out. If you know that e to the power of ln cancels. We're just left with the 20. Any questions here? Any questions on this page? All right, next, we're going to be evaluating logs in the calculator. So yesterday we talked about how most calculators only do the common log, so like log base 10. It doesn't even give you an option to change the base. We could put log of 8 in the calculator, but I couldn't do log base 2 of 8 in the calculator. You can't actually physically change the base in your calculator, but we have this change of base formula. So the change of base formula just allows us to put logs in the calculator. So we do that by taking the log of x. So the log of the big number goes on top and divide it by the log of the little number. So if I had something like log base 2 of 8, I could put this in the calculator by taking the log of 8 and dividing it by the log of 2. So I always think about it like if I cut it in half here, the big number goes on top. The number that's down low goes on the bottom. And then when we put this in the calculator, we can actually do it and see what number we get. So the number that's actually this little, not the smaller number, but the little one, the base goes on the bottom. Base on the bottom. So if we put it in the calculator, be careful. You may not be able to do it all at once. You can if you close the parentheses. So like in my calculator, I can do log of 8. I have to close the parentheses before I divide it by the log of 2. And this should give us 3. Remember, if you put it all in the calculator at once, you have to remember to close the parentheses before you divide it. All right, let's look at the next example. So to put this in the calculator, what would have to go on top? 6. So log of 6 divided by log 3. You can't just divide 6 by 3. It does not work that way. Put it in the calculator and see what you get. 2 decimal places is fine. So we should get 1.63. So this would be how I put it in the calculator. All right, let's look at the second one here. What goes on top? Log 5 divided by log 2. So you should get 2.32. Next, we're going to be graphing our logs. So we have 2 different type of shapes of graph here. The first one, looking at the base. So the base tells us a lot. That little number that's attached to the log, the base tells us a lot. If the base is greater than 1, our graph has this shape here. And it gets really, really close to the y-axis, but it doesn't touch. So it's not going to cross the y-axis. The y-axis, this one. It gets really, really close down here, but doesn't touch it. The red one is the graph here. This one. Now, if our base, that little tiny b attached to the log, little number, if it's in between 0 and 1, so if it's like a fraction or a decimal, our graph has this shape. Kind of just opens up like that. So as it gets higher to infinity, it gets closer to the y-axis, whereas this one, if it goes down, it gets closer to the y-axis when it goes to negative infinity. So you just have to know these 2 shapes here. And then also we want to know that the domain of our graph, depending on what this x is, so it might be like x plus 1 or just x, we would set that greater than 0. And then the range is always all real numbers. So let's look at example 7. So I'm going to draw my graph here. I'm also going to make a little chart here so I can plot numbers to give me points on my graph. So I'm going to pick values for x, plug it in, and then get my points x, y. Now there's 2 specific numbers that we want to pick. After that, we're just going to draw the shape of our graph. So looking at the base, before we even do anything, just looking at the base, we know that the shape of the graph is going to be like that. Thank you. So let's plug in numbers to figure out where exactly the shape is going to go on our graph. So we always want to start by plugging in 1. Whatever value makes this x 1. So I'm going to start with 1. So this is going to be log base 3 of 1. When we do the change of base formula, which number goes on top? Log of 1 divided by log of 3. Base goes on the bottom. Now, if you put this in the calculator, if you do log of 1 in the calculator, divided by log of 3, what do you get? 0. Because the log of 1 is 0. That's why we always pick 1 to plug in first. So you don't even need a calculator to solve this. If you have log of 1 on top, it's going to give you 0. So what would my point here be? The xy point. 1, 0. So go to my graph. I'm going to put a point at 1, 0. So I'm going to go to the right 1 and stay at 0. All right. Next. The next number we want to plug in is whatever the base is. So we're going to plug in 3. So here I have log base 3 of 3. This would be log of 3 divided by log of 3. Without even putting this in the calculator, just think about it. What do you think log of 3 divided by log of 3 is? 1. Same thing divided by itself is 1. So what would this point be? 3, 1. So I'm going to go to my graph. I go to the right 3 and up 1. You only need these 2 points, and then we can just draw our shape. We know that as we get closer to negative infinity, our graph gets closer to 0. So it's going to look like this. It's going to be kind of like this R type of shape. And that's all you need for your graph. All right, let's look at 19. So here, I'm going to draw my chart so I can plug in values for x and get my points. And then I need my graph too. So what's the first number that I want to plug in? 1. So if I do the log base 2 of 1, this would be the log of 1 divided by the log of 2. And without even putting it in the calculator, what is this going to be? 0, because anytime the log of 1 is on top, it's 0. So our point would be what? 1, 0. So let's put it on our graph. We go to the right 1 and stay at 0. What's the next number we want to plug in? 2. Perfect, because our base is 2. So log base 2 of 2 would be log of 2 divided by log of 2. Without even putting it in the calculator, just doing it in our head, what is this going to be? Log of 2 divided by log of 2. 1. So what's my next point? 2, 1. So I go to the right 2 and up 1. And then because our base is bigger than 1, we have that R-shaped graph again. It looks like this. And that's it. So 21, I have log. Well, let's draw a graph first for 21. So I need my little chart and I need my graph. My base here is 1/2. So is this going to have that same R shape that the other ones did? No. It's actually going to be the opposite. It's going to open up like that. So as we get closer to infinity, it gets closer to the 0 up top. So it'll look like that. I don't know what type of shape you think this looks like. Oh, like an L. It'll be like an L shape. So we're going to plug in values for x, get points for y. What am I going to plug in first for x? 1. So this will be log base 1/2 of 1. So log of 1 divided by log of 1/2. Without even putting it in the calculator, what is this going to be? 0. So my point is what, Tomas? 1, 0. So let's go to our graph. I'm going to put a point at 1, 0. What number am I going to plug in next? 1/2. So log base 1/2 of 1/2. This would be log of 1/2 divided by log of 1/2. What would this be? Perfect. The point would be 1/2, 1, because we get 1/2, 1. So we go to our graph. We're going to go to the right 1/2 and up 1. Now this graph is an L shape. We get really, really close to the y-axis up top, but we don't cross it, and then it just bends that way. Thank you. Right, so one more just to practice for the homework. This is going to be, it looks like number 60 in the homework, so a practice for number 60. It's not going to be the same numbers, but it's the same idea. So let's say I had f of x is equal to log base 4 of x plus 2. I'm going to draw my chart here, plug in values for x, get points, and then draw my graph here too. All right, now this one's a little bit different. 1 second. Because it's not just x, it's x plus 2. Typically, what numbers would we want to plug in here? 1 and 4, because our base is 4. But because this is different, because it's not just x, we want to plug in whatever makes this 1 and 4. So we want to plug in the value that makes x plus 2, 1, and the value that makes x plus 2, 4. So if you have something happening directly to the x like this, you have to find what values of x you want to plug in first. So here, I just solved for x. Subtract 2 on both sides. So x would be equal to -1. Do the same thing. Subtract 2 on both sides. So x is equal to 2. So the numbers that I actually want to plug in here are -1 and 2. So let's finish working this one out. We're going to plug in -1. So I have log base 4 of -1 plus 2. So we have to do the parentheses first. Log base 4, -1 plus 2 would be 1. What's log base 4 of 1? 0, because this would be log of 1 divided by log of 4, which is 0. So my first point is -1, 0. So I'm going to go to my graph here. I go to the left to -1 and stay at 0. Next, we said we wanted to plug in 2. So I have log base 4 of 2 plus 2. So this would be log base 4 of 4, which when we put it into the change of base formula, we get log of 4 divided by log of 4, which would be what? 1. So my next point would be 2 comma 1. So we go to the right 2 and up 1. Now, is this graph an L shape or an R shape? R shape, because it's bigger than 1. My base is bigger than 1, so it's an R shape. So we just connect our dots with an R shape like this.